Thanks for being here. I'm Bowen, and today I want to talk about Nightshade 3.0, the next evolution of Near Protocol. So before we talk about the future, I want to take a look back at the last 5+ years of amazing development of the protocol since we launched mainnet in October 2020. We've maintained 100% uptime, which is a rare achievement in the blockchain space. And not only that, we've made great progress in terms of scaling the blockchain, improving the throughput, and we did this redesign of the protocol based on stateless validation and launched the Nightshade 2.0 design in August 2024, made the blockchain fully sharded, both transaction processing and state are fully sharded. And not only we actually designed this highly scalable architecture, implemented it, and we also proven the scalability in practice. We now have 9 shards on mainnet, and in December last year, we ran this test on the 70-shard network and proved 1 million transactions per second in this public benchmark that anyone can actually run. And it's also the improvement is not just about scalability, it's also about the speed. We've actually decreased block time by half last year, and now we have 600 millisecond block time, 1.2 seconds time to finality. And overall, I would say in the past 8+ years since we started working on Near, we've built this fast, scalable, and very reliable blockchain. So all of that sounds great. The question is, what challenge do we still face today? So I would say there are a couple. One is the asynchronous execution that comes with the sharding design. So this is how we allow the blockchain to scale and to have this ability to linearly scale with number of shards. But it also comes with some problems. One of the problems is that even though the blocks are very fast, produce every 600 milliseconds, some transaction may actually take several blocks to be executed. So the reason is that the transaction was first executed on the shard of the sender, then generate a receipt, go and send to the shard of the receiver, get executed there. And if you're calling a function, then that may actually generate more receipts that go to some other shards to be executed, which will be the case if you have a complex DeFi transaction. So that's a problem for users, and it's actually a bigger problem for developers who need to write those smart contracts, especially when it involves this multi-contract interaction. The main problem is that you need to handle the cases when the cross-contract call fails, and actually you need to attach this callback to make sure the state is restored in a correct way, making sure there's enough gas attached to it so that the callback doesn't fail, and so on and so forth. So overall, that's actually a sticky point in Near's developer experience. So another problem is how we manage storage. So we introduced this storage staking mechanism when we launched mainnet in 2020. The idea is that in order to occupy some state on the blockchain, you actually need to lock down Near tokens to do that. And there's a fixed conversion rate between the number of tokens you lock down versus number of storage amount of bytes you can get in the state. So all of that was fine, except that when it actually gets used more and more, so problem emerge. So basically for both developers and users, this is not a great experience. So developers need to think about how to actually charge for storage on the smart contract. For example, when a user does smart contract call, let's say they write some more bytes to the state, then they actually need to get charged more because they actually increase the storage staking requirement for the contract. And if you don't do that, then obviously people can abuse this, and so the contract can run out of storage and so on. And for users, it's also annoying because if you actually do it correctly, then for some contract call, you may need to attach a variable amount depending on how much state you plan to write to the contract. So that's going to be very annoying. So what happened in practice is that many popular smart contracts actually give up on managing the storage properly. They either just say they will subsidize the storage management, the storage staking cost, or because it's some DeFi contract, they already have a lot of Near in some pool or something else that they already have enough Near to pay for the storage, so they don't actually worry about managing the storage properly. So we actually introduced a partial escape hatch in 2023 called zero balance account. The idea is that back then, the cost of creating near account is actually expensive because in order for the account to even exist, you need to have enough near locked in the state for the storage, and that actually makes it actually very high cost to acquire new users. So the idea of zero balance account is that if the state of the account is under 770 bytes, then you don't actually need to maintain any balance on the account. Essentially, the creation cost of the account is paid for as part of the transaction fee when the account was created. Okay, so here I talk about some of the problems we face today. And I want to give a bit high-level overview of a number of different initiatives we're working on to make the protocol better. So I would say each of them requires own presentation to do a deep dive. And here I'm mostly giving a high-level overview of how those initiatives are and some of the thinking behind. So the first one is called SPICE, which stands for Separation of Consensus and Execution. This is the idea that the consensus should not get blocked on execution. This would allow a consensus to run faster, blocks to be produced faster, because unlike today, the validators won't need to actually apply all the transaction and receipt to the state transition update in order to produce the next block. So they would not only lead to faster block time, but also generally better utilization of the hardware resources and the result higher throughput. So it also makes the execution model much more flexible because the execution does not need to actually update every single block. It can update asynchronously every several blocks. So the new state root don't necessarily need to get posted every block. And this has some very interesting properties. For example, it allows for transactions that are more long-running than today. So you don't necessarily need to get limited by the gas limit of single block. It can actually run for like longer period of time. And also it allows for time to generate zero-knowledge proofs, which would address one of the scaling bottlenecks, which is the network bandwidth usage on transmitting state witness. It also makes the state witness much cheaper to verify on the stateless validator side. So here is an illustration of how roughly it would look like. There's this consensus chain that just keeps running forward, producing blocks, packaging transactions. And there's this execution chain that keeps catching up. It executes transactions and receives the state update. And every once in a while, it will post the state update on chain. So we talked about the problem with storage management. So the idea to address it is that we want to decouple the actual state storage from execution. So we want to have this concept of stateless executors and have them separate from the state storage nodes, which can be very heavy and can store the state of many shards at a time. So the observation here is that if we don't actually need to replicate the state storage on every single chunk producer node for the shard, then the state will become even cheaper than what we have today, which is already good with the sharding and so on. So the idea is that if we can do that, then we can further reduce the cost of storage and actually replace the storage staking with gas payment for the state storage. Essentially, you just pay for writing to the state as part of the transaction fee, similar to what we did for the zero balance account. And you don't need to worry about storage staking, which is a major pain point for both developers as well as users. And I also talk about the problem with asynchronous execution. So I want to talk about this optional atomic transaction that we want to introduce. So basically, the idea is that today, transaction would specify who the receiver is, and based on that, it actually gets executed on the shard of the receiver. But you can think of it as actually it's specifying that it's going to touch this key that represents this piece of account, a piece of state in the blockchain. And the idea is that the transaction should have the ability to specify the list of state keys you're going to touch during the execution, and today's transaction is just a special case of that. So the idea is that the executor would actually pull the state specified from the state storage nodes or already have them cached locally with this public contract, and then can execute the transaction synchronously. And here, the actual SPICE design is key to this because it actually allows for longer running transaction where it takes longer to pull the state if you touch a not so popular contract or account. And for the popular ones, the executor should already have them cached locally. So this is roughly how the flow would look like. You have this transaction, it specifies the list of keys that's going to touch, and then the executor, when they execute the transaction, they would actually pull the state from potentially different state nodes, and then does the execution in atomic fashion. Obviously, there are still a lot of unresolved problems here. For example, how do you resolve the cases when multiple transactions need to touch the same state, and how do you minimize failure of transactions in those cases? So yeah, a lot of work ahead of us. So far we talked about decoupling consensus from execution, decoupling execution from state storage, introduction of atomic transactions on near, and also removal of star staking. I think altogether they already give rise to a much faster, more scalable blockchain with much better developer experience. But there's another thing I want to talk about, which is privacy. So as more financial activities move on chain, I think the right to privacy is becoming increasingly more important. So businesses do not want their payment information and payment history to be publicly visible, and individuals do not want their assets or transactions to be seen or analyzed publicly. But introducing privacy is definitely not an easy task because you want the blockchain to have both private state and public state. This is because for a certain smart contract, having the transparency, having the state being public, having the auditability of the state is important property on its own. So you want both to exist. Obviously, there's still a lot of work to be done on actually properly designing how the private state will look like. But our current thinking is as follows. The validator will run inside the trust execution environments and using the confidentiality that comes with the trust execution environment to provide privacy for the state. There will be the accounts and contract that actually live inside the trust execution environment with some metadata being public. And then you have composability between the private contracts and composability between the public contracts, but the public contract will not be able to call the private contracts. And then the users will have what's called like a viewing key. This is an instrument that allows them to view the state of their own on the general private state of the blockchain. So roughly it will look like as follows. The on-chain state roughly split into the private state and public state. So they can interact between each other, but the public contracts cannot call the private contracts to avoid leaking data. And then the users would have this thing called viewing key. It can view its account on the private state or certain data on the private contract in the private state. For example, some balance on a fungible token contract can only view its own balance and cannot view other people's balances and so on. To summarize, I talked about quite a few exciting features that we plan to build that together shape Nightshade 3.0, which is our vision for the future. It's going to become a much faster and more scalable blockchain compared to today. It's going to be much easier to develop than today, and we'll also have built-in privacy. And actually, Alex will talk about tomorrow how this privacy part will play an important role in near intents. And that's it for my talk. Thank you for coming.